Well, good morning. Moving on to this, I hope you do both of these. I think if you do both of the practice finals I gave you, I think you'll have a really good chance. There's lots of good stuff in these things. This is a very, very good question, especially for a non-calculator test. The value of log 3 of 27 is what? What it's asking is what power of 3, which is your base, right? That's your base, equals 27. So I know 3 cubed is 27. So there's my power. Just expect something like that. Like if you saw log base 5 of 125, I know that 5 cubed is 125, so 3 is still my answer. Be on the lookout for things that are simple. I don't know that the answer will always be 3, but it's a pretty common number. A lot of times we don't do fourth because kids in fourth powers usually aren't that good. All right, find the horizontal asymptote and vertical asymptote of the following. Now, I know the answer for the horizontal asymptote is going to be a third, but if you want to find an asymptote, your horizontal asymptotes and obliques are always quotient of long division. There are 3 shortcut rules for these, but kids never seem to remember the blasted things. So just do long division. It always works. So we're going to enter x squared plus x minus 2 with 3x squared minus 4x minus 20. And to turn a 3 into an x squared, I have to multiply by a third. And then I invoke the distributive property. I'd have x squared minus 4 thirds of x minus 20 thirds. And it's not going to be hard. It's a horizontal asymptote. It's not going to be hard. You're supposed to subtract, and I'm just going to do that to show you what happens. X squared minus x squared is nothing. X squared plus 4 thirds of x is 7 thirds of x. And right now I can stop, because unless I use negative exponents, I cannot turn x squared into an x. So whatever's going to be down here is my remainder. And all I care about is the quotient. So the horizontal asymptote is a third. That would be this guy or this guy. So long division made it 50-50. Your vertical asymptotes are found by simplifying after factoring. Now x squared plus x minus 2 does factor. I think it does. I think it's x plus 2 and x minus 1. And let's see here. Our denominator is going to be 3x and an x. Factors of 20 are 5 and 4. Right? Which doesn't work. 2 and 10 doesn't work. It's got to work. No, I'm just being stupid. Yeah, it's 2 and 10. We want to be negative 4x, so plus 2 minus 10. And what cancels here is these two. The VA is at 3x minus 10 equal to 0. So 3x is 10, and x is 10 thirds. I seriously doubt you'd be asked here, but the hole in the graph is at x plus 2 equals 0, or x equals negative 2. They just wanted the vertical asymptote, which is at 10 thirds. Oh, I don't know why I chose that one. Wrong one there. When I say 10 thirds, it's this guy right here. Notice that distractor right there? That's the hole. All right, find the oblique asymptote of the function. And again, horizontal oblique asymptotes are always the quotients of long division. I'm going to put placeholders in. You don't have to use placeholders, but it helps. To turn an x squared into an x cubed, I need an x. And then it'll give me, when I distribute x cubed minus x squared plus x, right before you subtract, we'll have a positive x squared minus an x, bring it down at 1, 2. To turn an x squared into an x squared, you need 1. And when you subtract here, you get this negative 2, which is your remainder. All you care about is the quotient. Notice it says quotient. Quotient. So y equals x plus 1. Kind of hard to understand that unless you look at a graph and you don't have a calculator. So you just got to accept it for what it is. Find the domain of the function. Not a hard problem. Golden rule is thou shalt not divide by 0. So I know that 2x plus 8 shall not be 0. That'll tell me that x cannot be negative 4. Plain and simple, can't be negative 4, which means you can be everything else. Now, some kids struggle with that, but you can be everything else. You know, you think about a number line, if you're one of those kids who still struggles, open hole at negative 4, you can be everything left and you can be everything right. So that's going to be choice C. Solve the inequality. I know how kids feel about inequalities, nothing I can do about it. You do need to put these two things together. The two terms on the left need to be added together. And what we'll do is we can't just x minus 2 everything, because 2 is a critical value. What we can do, though, is we can turn that 1 into x minus 2 over x minus 2, because that is 1. Then we can start adding fractions together. 1 plus negative x plus an x is no x, and 1 plus a negative 2 is negative 1. So negative 1 over x minus 2 is bigger than 0. That's the deal. We kind of get to invoke the rules about number 21. When I look at this thing, there's not a whole lot you can do with it. Like if you x minus 2 both sides, you'd still have a 0. So it doesn't make much sense. This right here is going to be a critical value. I know I cannot divide by 2. So x cannot be 2. And I can take that and put it on a number line and I can plot around it. So I'm going to test a 0 and I'm going to test maybe a 3. And I'm going to go back to the original function. If I test a 0, I'd have 1 minus 0 over 0 minus 2 plus 1, hopefully bigger than 0. And 1 minus 0 is 1. This is negative 1/2 plus a 1 bigger than 0. And that is true. So everything to the left of that vertical asymptote is going to be accepted as being bigger than 0. If I plug in a 3, 1 minus 3 over 3 minus 2 plus 1, this is going to be negative 2 over 1. So negative 2 over 1 is negative 2. That's false. So none of this gets used. Your solution space is from negative infinity to 2. And I realize that you'd have a hard time accepting that as true. So even though you can't use it on a calculator or on a test, let's just take a look at the graph so you can at least trust what Milbrath is telling you, because sometimes, hell, I'm wrong, aren't I? You know, everybody's wrong about something. I happen to be wrong about a lot of things, but I happen to be right about more than I'm wrong. See, zoom 6. Oops, zoom 6. So here's negative 2 on my graph. Look at that thing. Look how mean they are. It just barely looks like it's less than 0, and there's something going on over here. Oh, sorry, 2 is the deal. Right there. Oh, I want greater than 0, don't I? So there's negative 2. When you're bigger than 2, Well, this is just quite the conundrum. Let me check my math on the 3. -2. Oh, that's false. Well, fudge dudge. What's going on here? I agree with this right here. I wonder why the other side didn't work. Did I make a mistake? No, I didn't make a mistake. I'm just having a moment. These values are less than 0, aren't they? I'm sorry I wasted your time. Got confused. Should have just stuck with the algebra. All right, solve the following inequality. It's kind of the same deal. We did one of these yesterday when I was doing some notes with you. What you're going to do is you're going to factor to find critical values. Factors of 8 would be 4 and 2. So what? Need a positive 2 plus 4 minus 2. Your critical values are at -4 and positive 2. And then you got to think about things on a number line. That's the reason kids don't like inequalities. I have an inequality symbol, so open holes. 99 out of 100 times, there's usually a pattern here. Like if I accept this, I'll probably accept this and I'll throw away the middle. It's not always true though, so you just got to check it. So let's see here. Something to the left of -4 is a -5. Something between -4 and 2 is 0, so I'll test at 0. And something to the right of 2 is a 3. So those are the things I'm going to test. If I plug a -5 into the inequality, I'd have 25 minus 10 minus 8. And if I put that together, oh, I get 7. 7 less than 0, definitely false. None of that's gone. This is probably going to be an accept the middle kind of deal. If I plug in a 0, I get -8 less than 0, which is true. So I get to be from here to here. And then I'm going to plug in a 3. If I plug in a 3, I'd have 9 plus 6 minus 8, which is 7. And I get 7 less than 0, which is false. So I throw away that. I get to keep the territory between -4 and 2. Choice B. I'm going to pause this real quick, get some fresh air, and see what my wife wanted because she just sent me a message.